Right, so welcome to this segment. So we are now looking at area enclosed by a curve and the y-axis. So suppose the area that you're considering is enclosed by the curve and the y-axis. So you can see if it is enclosed by the curve and the y-axis, it simply means the limits are going to change. So let me say this is A and that is in this case B, but of course if you notice my A is actually less than my B. That's what we know. In other words, B is the upper limit and A is the lower limit. So what we do when you have been given any function of a curve, you need to make x the subject of the formula such that it will be x is equal to now in terms of y. So x will be in terms of y. So that is why we are saying the area enclosed by the curve x is equal to f of y, the y-axis and the lines y is equal to a and y, where our a is less than b is simply going to be given by, so it is going to be given by, you just need to integrate, remember the upper limit and the lower limit, so you integrate x with respect to dy. Why? Because you know what is changing is actually in the y-axis, so that is going to be dy because it's the one changing. Now remember, this is going to be true when this x that we have there is represented by the function of y, but it should be greater or equal to 0. So this is the expression that we are going to be using in order to calculate the area enclosed by the curve and the y-axis. In simple terms, if you have been given y is equal to x squared, it simply means you need to make x the subject of the formula. What do? You can introduce the square root, introduce the square root. What I do, meaning x will be equal to the square root of y. So this, now where there's x there, you are going to replace this so that you integrate it with respect to dy because it is the one that is changing. Now, like we said in the previous discussion, you are going to find that the area or the region on the left of the y-axis, so the region on the left of the y-axis will be also treated as negative. Just as you are treating the area on the right as being positive, the area on the left of the y-axis will also be negative. So therefore, if the area on the left, you can put up a negative and actually integrate it like that. So put up a negative, or if you want, you can simply say the modulus of x with respect to that. So that is the way you can do it, of course, if you're having your upper and your lower limits. Now let me just show you a sample question on how you can go about it. So it says the figure shows part of a sketch of a curve y is equal to, so it's y is equal to x raised to the power 3. Calculate the area enclosed by the curve. This is the curve, the y-axis, that is the 1, and the lines are y is equal to 8 and y is equal to 27. So they want us to find that area. So like I mentioned, you need to make x the subject of the formula. That is what you can simply do. Of course, there are so many ways you can do it. You can multiply probably by the reciprocal such that it becomes x is equal to y raised to 1 over 3, or you can introduce the cube root. So it's the cube root of y and there the cube root of x. So this and that will cancel. X will give you the cube root of y. But according to the laws of indices, remember this can be written as 1 over 3, and that is why we are having that. So therefore, to find the area, when you make your x the subject of the formula y is equal to 1 over 3, now you can find the area enclosed. So the area enclosed will be equal to, you integrate, remember the upper limit 27 and the lower limit is 8, then that will be x with respect to dy. So now we can replace what our x there is, because I've already made subject of the formula, which is y raised to 1 over 3 with respect to dy. So we can actually get to integrate that. So remember, when you integrate, you simply add plus 1. So it's like 1/3 plus 1, it will give you 4/3. So therefore, it will be y is equal to 4/3 raised to 4/3 divided by the new power, which is 4/3. So this is what you are going to have, and you can put up your limit 27 and 8. Now, if you notice there, what I can do is that, divided by 4/3, this is the same as me writing it as 3/4. So it is going to be, I can just simplify that. If you divide, it will just flip, so it will be 3/4. Then that is going to be, if you notice, y 4/3, this is going to become the cube root of y, whatever we have raised to the power 4. According to the laws of indices, if you have a raised to m/n, that becomes the root, then the a, then whatever you have raised. So this is the concept I'm using. So therefore, it is going to be the cube root of y and whatever I have, raised to the power 4. So this is what I'm having, and that is going to be 27 and 8. I've just tried to, simplify it. Like we said, under calculus, you're going to be using a lot of, these laws of indices. So we can substitute the upper limit and the lower limit. So how is that going to be? It is going to be 3/4. So that is going to be 3/4. If you notice the cube root, my y is a 27, whatever I get raised to the power 4, whatever I get there, subtract the lower limit, which is 3/4. That is going to be the cube root of 8 raised to the power 4, and that. So the area is going to be the cube root of 3. What is that number? When you multiply it 3 times, it will give you 27. It is 3. But if you say that is 3, but 3 raised to the power 4, that will give you 81. So it is going to be 3/4 multiplied by 81. But remember, you can actually try to work out that. Minus the cube root of that is going to be 2 raised to the power 4, that is a 16. So you are going to have, in this case, multiplied by 16. So if you look at that, if you multiply 3/4 multiplied by 81, that is going to give you a 243/4 minus 4 there, 1 4 there, that is a 4 times that will give us a 12. So this value, 243/4 minus 12, that is going to give you, that is going to actually give you, in this case, 48, 3/4, and that we are going to write as mean square unit. So this is the way you can actually find, the area. So this is the final answer, that we are getting there. So that is the way you can go about it. Please just make sure you practice, you go through, watch out for more videos. I'll show you how to find certain areas, like areas, enclosed by maybe 2, caves. So that is what I'm going to show you, and show you how you can calculate that in the exam. This is a simple topic, and hence you can look at it, a revolution. Later on, we'll look at volumes. Thank you so much for watching.